Hello everyone, welcome to Online Study for You. In today's video, we will be discussing some of the pseudocode sample questions that are nowadays being asked in Infosys exam. So before moving on, there is an announcement from Online Study for You. We have launched Infosys Cracker course that contains more than 100 videos that can help you in these exams. So you can avail this course at a price of discounted price of 599. The link to this course is in the description, so you can check this out. So now let's move on to the first question. Nowadays, Infosys is asking a lot of questions that are related to time complexity. So in this first question, we have to find the time complexity of this pseudocode. So just a brief introduction about time complexity. That in time complexity, we are concerned about the total number of unit operations. And my time complexity is a function of input size. Let's see this question. You will understand both of these things through this question only. So my A is 0, right? My A is 0. This is counted as 1 unit operation. This is 1 unit operation, right? Now my I loop is from 0 to n. And for every I, my j runs for some times, right? So and for every iteration of j, there is 1 unit operation. For every iteration of j, there is 1 unit operations. So we will count the total number of unit operations that is in the code. 1 unit operation is here, and for every iteration of j, there is 1 unit operations. So basically, we have to just calculate how many times the loop runs, and that will give me the total number of unit operations, and then we can calculate the time complexity. So for I is equal to 0, my j runs from n to 1, right? So basically, the total number of unit operations for this iteration is n, right? Let's write it here. For I is equal to 1, my j runs from n to 2. Why from n to 2? From n to j greater than I, j greater than 1, so that is 2. So this is equal to n minus 1 unit operations, because if this was n, obviously this is n minus 1 because we have reduced one step. So this will be n minus 1 unit operations. If I is equal to 2, j is equal to n to 3, that is equal to n minus 2 unit operations. That is equal, we'll add it here again. For I is equal to 3, j is equal to n to 4, that is n minus 3 unit operations. We'll add it again, and here's a pattern, right? What is the last iteration of I? That is I equal to n minus 1. For this, my j will run to n to n, that is 1 unit operation. So we'll keep adding, and it will go till n. So this looks very familiar to me. I'll just write it in some other way. 1 plus 2 plus 3 plus 4 dot 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 plus n minus 2 plus n minus 3, sorry, n minus 1 plus n. This is sum of n natural numbers, and that is equal to, we have read it in AP, right? N into n plus 1 or minus 1 by 2. Okay, it doesn't matter. N plus 1 by 2, and okay, yeah. So this is equal to n square by 2 plus n by 2. These are the total unit operations, and adding this here also, the total number of unit operations are n square by 2 plus n by 2 plus 1. So in calculating the time complexity, we are always concerned about the highest power term, and that's why it doesn't matter if it is plus or minus, right? If I would have taken minus also, it wouldn't have made any difference. So we are only concerned about the highest order term. So, and we also omit the constant. This is 1 by 2 into n square, right? So we are only concerned about this term, and we say this is my time complexity. So the time complexity of this code is big O of n square. I have discussed more about time complexity in the Infosys Cracker course, so you can check this out there as well. So yeah, this was pretty much about this code. Let's move on to the next question. Okay. So in this question, we have been given a pseudo code alongside performing binary search in an array of elements. Okay. So this is a pseudo code of binary search, and we have to complete the third part. I'll just tell you what binary search is. I'll give you a brief introduction about binary search. So let's say we have a value to be searched in an array. For that, we perform binary search, right? So what we exactly do, we have a start. We make the end, that is n minus 1th index as end, and we make the 0th index as start, and then we find the mid index, that is start plus end by 2. And now we compare this number. Let's say this number is y, right? We find this number, the middle number, the number which is present in the mid index. And now there are three possibilities. Either this number is equal to val, either this number is greater than val, and either this number is less than val. And there is one major thing in this, that this array is sorted in ascending order. This is a necessary condition for binary search. The array needs to be sorted in either ascending order or descending order, right? So we are talking about the arrays sorted in ascending order. So there are three possibilities, that the number which is present at the mid index is equal to val. Compare x with the middle element, and if the x matches with the middle element, so yeah, we have found our value val. So we simply return the index, the mid index that is present here. But if this is not the case, there are two conditions, that the number that I found here, the number that I found here is greater than the value, right? This value is the value that is present here, the mid value is greater than alpha. We'll first discuss about this case, right? The mid index value is greater than value. So in this case, we know that our val is less than this. So obviously this will be present in this half, right? Obviously, because val is less than this. So since it is sorted in ascending order, so my val will be less than these as well, right? It is sorted in ascending order. So if my value to be searched is less than this, it will be less than these numbers as well. So I have to search in this area, right? So that is the S part. If x is small, x is the number to be searched, recur to the left half. I mean, I have to search in this half. Contrary to this, if the second case, if this value is less than the number x, if this value y is less than val, so obviously my val will be greater than these elements as well. So we have to search in this direction now. So this is the third we need to do, that else if x is greater than the mid element, then x can only lie in the right half of the mid element. So we recur to the right. So B is the correct option, right? So this is the entire binary search. We'll just take an example so that it helps you. 5, 6. Okay. Let's say I have to search 2. And at some point of time, I got here. Okay, this is my y. This is my y, and this was my val, right? So since it is sorted, this is not equal to the number. So I have two options now. Either I have to check in this direction or this direction. So obviously, y, this is greater than val. this is greater than val. So obviously I have to search in this direction. The number, this case, x is smaller, val is smaller. So I have to recur to the left half. Contrary to this, if I have to search 6, right? So in this case, my y is less than val. So in this case, I have to search in the right direction. And this is how the algorithm of binary search works. I hope this is clear to you. Let's move on to the next question now. In this case, we have to predict the output of the following pseudocode when the value of n is 35. Okay. So initially, I is 0. And there is a while loop which says I have to keep iterating unless n mod 10 is not equal to 0. What does this statement means? This means we have to divide unless n is completely divisible by 10. What does mod operator do? It gives me the remainder. So I'm basically asking, keep this, okay, actually it is saying not equal to 0. So I have to keep this loop unless this n is not completely divisible by 10. I have to keep doing that, doing it until that time. What does mod operator do? It gives me the remainder. So I'm saying when I divide it by 10, and if the remainder is not 0, that means if it is not completely divisible by 10, then go inside this loop. This is the scenario here. So let's work on it now. Initially n is 35. So I'll check if 35 mod 10 is not equal to 0. Yes, obviously it is not completely divisible by 10. So my remainder is not 0. So I'll come here and say n is equal to n plus 3. So n was 35. So 35 plus 3, 30, that is 38. And then I'll say I plus plus, and my I goes to 1. It was 0 initially and it went to 1. After that, I'll again check if n mod 10 is not equal to 0. Now my n is 38, right? So 38 is not divisible by 10, right? So it will go inside the loop. Now 38 plus 3, that is 41. And I goes to 2 because I plus plus. Again, I'll check if 41 is not divisible by 10. Okay, no, it is not completely divisible by 10. So again, I'll repeat the process. That is 41 plus 3, that is equal to 44. And I goes to 3. Again, I'll check if 44 is not divisible. Yeah, it is not divisible. It's equal to 3. So it is 47 and it goes to 4. I'll again check if 47 is not divisible by 10. Yes, it is not divisible by 10. So 47 plus 3, that is 50, and I goes to 5. Now, in this case, I'll check if 50 is divisible by 10. It will say, yeah, it is totally divisible by 10, because 50 mod 10 is equal to 0, and the condition does not satisfy. So it will come out of the while loop, and now n is equal to n plus I. So what is the value of n? That is 50. So 50 plus I, what is the value of I? It is 5. 50 plus 5 is equal to 55. And that is my answer, because I have to give the output of n. I hope this was clear to you. Mod operator basically gives me the remainder. Let's move on to the next question now. Okay, let's now look at this question. What is the time complexity of the following pseudo code? So by looking at one go, I can say that it is the code for binary search. Those of you don't know binary search, I have discussed this in the previous lecture, previous question only. So this is the code for binary search, and we have to basically find the time complexity of binary search. So I can calculate it with the help of an example to show you. Let's say this is my array, right? 7. This is my array. Just mark the indexes 2, 3, 4, 5, 6, 7, right? So first I'll say this is my, I'm going according to the code, right? This is my BEG, and my end is size -1. That is here. This is my end. And I'm keep iterating else until my BEG is less than or equal to end. Basically, this says that my beginning is on the left of end or equal to end. I have to keep iterating until then. Now I'll calculate the mid index, that is BEG plus end by 2. So that is in this case 0 plus 7 by 2. This is my mid index, right? So this is equal to 3. Let's say I have to search for an item. Let's assume that we have to search for 1. The value to be searched is 1. Let's assume that this is the case, right? So 0 plus 7 by 2, that is 3. So I'll check here. This is my mid index. This is my mid index. So I'm checking if the number, if this item, let's say item is equal to 1, right? So if my item is equal to array at mid index, what is array at mid index? That is 4. Is 4 equal to 1? No, it is not, right? So this case does not satisfy. So is item greater than array at mid index? Is 1 greater than 4? No, it is not. So we have to search in the left half, right? So what have we done? For that, we have marked end is equal to mid index minus 1. So I obviously now, since my 1 is less than 4, since my 1 is less than 4, obviously it cannot be present in this half. So what I did, I brought end to here at this point, right? And now I again repeated the process. This is my beginning, this is my end, and now I'm calculating mid index again. So this is my iteration number 1, for which I did k unit operations. Let's say we did k unit operations. Now again 0 plus 2 by 2, that is 1. So here, so I'm again checking if 2 is equal to 1. No, it is not. Since 1 is less than 2, again I have to search in this half, not in this half. So what I'll do, I'll bring end was present here, right? So I'll bring end was present here. So I'll bring end from here to here. So now my beginning and ending is pointing at the same point. This was my iteration 2, for which I also did k operations. Now mid is equal to 0 plus 0 by 2, that is 0. And now I'm checking if 1 is equal to 1, because array at mid index is 1, right? And now I'm able to find my 1. So I'll return the mid index. So for this also, let's assume for time complexity, we are concerned about the approximate value. So let's say for this also we did k unit operations, right? So how many unit operations did we did? 3k unit operations, 3k iterations. So for n, that was 8, we did 3, right? So we can say that 2 to the power 3 is equal to 8, right? If we try to make the number of iterations, right, number of iterations as a function of input size, so we can say 2 to the power 3 iterations was equal to n, right? So we can say log base 2, we can generalize it, 8 is equal to 3. So in general, log base 2 of n is my time complexity, the complexity that I take. So this is equal to log of size, log base size. We assume that it is 2. Okay. It will always be written as log of size. So you have to assume that 2 is written here. That is same. So yeah, this was the time complexity of binary code. And you should also remember this. This is a very standard algorithm, and we always remember the time complexity of some of the programs. And for the time complexity of binary search is log of n. Again, I have discussed this in detail in the course, in the Infosys Cracker course. So you can obviously check that out. So let's move on to the next question. Okay. Predict the output of the given code if the value of number is 6. Fine. So my read number. So initially my number is 6 as given in the question. Now k is equal to 2. right? And I is equal to 2 as well. And my number is 6. While I is less than number, while I is less than equal to 6. Fine. So K is equal to K into I. K is equal to K into I. That is 2 into 2. K into I. So that this becomes K becomes 4. Right. And I is equal to I plus 1. So my I becomes from 2 to 3. Again, my I is 3. That is less than 6. So I'll again do it. K is equal to K into I. What is the value of K? It is 4. What is the value of I? It is 3. It is 3. So that is 12. Right. So I is, and now I goes to 4. Again, my I is less than the number. So K is equal to 12 and I is equal to 4. 12 4 is 48 and I goes to 5. Fine. Again, my I is less than the number. So K is equal to 48 into 5. That is equal to, let's calculate it. 8 5 is 40, 5 4 is 20, 24, that is 240. 240 and I goes to 6. And now I is less than equal to number. So yes, 6 is less than equal to 6. Equality is there, right? So there is one more iteration. K is equal to 240 into 6. So let's calculate it. 24 into 6. So 6 4s are 24, 6 2s are 12. That is 144 and 0. 1440 and I becomes 7. Now 7 is greater than this, does not satisfy. So now I have to print the value of K. What is the value of K here? 1440. So B is the correct option. So this was the entire working of the pseudo code. I hope this was clear to you. So yeah, this is all for this video. I hope you liked this video. If you like our content, please like, share, and subscribe. And you can also share this video to those who are preparing for the competitive exams like this. See you next time.